It's recording now. Systems of linear equation again. Using matrices. This is the idea. Okay, what is the advantage and disadvantage of this? Okay, so far we study a linear system of equations in 2 dimensions and 3 dimensions. But in the real life, in the engineer application and the scientific applications, we have more than 3 dimensions. So we have, you know, 21 equations and 21 unknown. And solving this using the technique, the classical standard technique of the substitution or elimination is crazy because there are infinity possibilities. So now this is a challenge. This is a crazy problem, no? And fortunately, the mathematician create the algorithm for solving this. This algorithm is almost 100% in the same way, independent of the system you have, right? So we study in this chapter not only one, we study 3 different versions of this algorithm, no? And when you face your problem, and of course, this algorithm is a way to travel in this journey, but this journey is too long. Entonces, doing by hand is almost impossible, right? Now, I want to illustrate, there are different software can help us to solving this problem in the easy way. And the most important in this is the interpretation. So interpretation, so you have a system, you have 5 equations and 5 unknown. So what is the answer of this? And you are doing in several minutes, not too long, and your interpretation, but okay, the interpretation sometimes is hard because you have, remember the 3 possibility of the linear system of equation. We have unique solution, only one. You have infinity many solution or no solution, no? Infinity many solution, that different version because depending of the amount of free variable you have. I don't know if you remember very well the concept of the free variable, but we see in detail in this chapter, okay? Because maybe it's the solution set is infinity, I know, but it's a line, or it's a plane, or it's a hyperplane. Because when you are talking about more than 3 dimension, the 3 dimension we cannot graphic. It's impossible graphic, but algebraically, yes, we can manipulate. And the interpretation, each equation in more than 3 dimensions is a hyperplane, que es one concept beyond the plane. It's a plane in 4 dimensions, 5 dimensions. This is called hyperplane. But okay. Let's try today to explain how you represent the system of the equation using matrix, the different versions. And I suppose in the last moment, I solving at least one example. Okay, so let's start. I like to explain this, not using theoretical part, not using example. No? Suppose the first example is x minus 2y plus 3z equal 4. Equation 1. 2x plus y minus 4z equal 3. Equation 2. Minus 3x plus 4y minus z equal negative 2. Equation 3. This is existing. This is doable by hand because it's 3 dimensions. But this is not the goal. The goal is how you define the matrix associated with this. No? There are 2 different ways. The classical way is you assume the system like that. Capital A, capital X, capital B. The capital letter is for the matrix. So the matrix capital, the notation, and the matrix have a dimension. And dimension indicate, for example, capital A, I suppose it's 3 by 3. What means 3 by 3? 3 by 3 means this is a row and this is a column. So the number of the row and the number of the column. Columns. So suppose this matrix is formed only for the coefficients in front of the variable. S1 and negative 2, S3, S2, negative 3, 4, and negative. This matrix is a matrix A, and is the matrix square, S3 by 3. It's called a square because square matrix, in singular F matrix like that, in plural F matrices, because the number of row and the number of column is the same. Okay, you need to be familiar little by little in the chapter with this terminology. Square matrix is 3 by 3, 4 by 4, 2 by 2, when there's the same number of row and column. And this is dimension, guys, dimension. And by convention, the first number is row and the second is column, always, always. Entonces capital X, who is capital X? Bueno, capital X is, wow, capital X is another vector, another matrix, sorry, que es XYZ. Entonces es the vector formed by the unknown, que es X, Y, and Z. Y frequently write in this format. This format is called the dimension is 3 by 1 because we have 3 rows, 1, 2, 3, and 1 column. And when the situation happens, this is called a column vector. Column vector. So vector is the specific terminology when the one matrix, the dimension is 1, it's called a vector. So vector is a particular example of the matrix when at least one dimension is 1. No? So this is a column vector. Likewise, we have maybe a row vector. Well, in this case, B is this vector que es 4, 3, and negative 2, que is the same as 3 by 1, so 3 row, 1 column. But we have another possibility is 4, 3, and negative 2, que is a row vector. Row vector. And the dimension of this guy is 1 by 3. So we have one row and 3 columns. So far, guys, the new thing that we are learning is new representation of the linear system of equation using matrix. Matrix is like a array of number. Let's see the application and how you manipulate. But no, so far is understand how you form the matrix. Okay, so now we have different kind of matrix. Square matrix is when the number of row and the number of column is the same. And we have another special case, it's a vector, is when at least one dimension is 1, maybe column vector or row vector. And you say, well, professor, 1 by 1, we have one possibility. Yes, but 1 by 1 is a scalar. So I suppose 2. 1 by 1 is just 2. Okay, so but in this case, no. We are working with a multi-dimension object. Okay, that's it. No, we have another representation, que es the representation that we want to work in today, que es the augmented matrix. Augmented matrix. Augmented matrix is the combination A and B together. So A and B together. It's A and B together, separated by one line. Okay, this line discriminate the left-hand side and the right-hand side. So what is the augmented matrix in this specific example? Is 1, -2, 3, one line que discriminate left-hand side, right-hand side, 4, 2, 1, -4, 3, and -3, 4, -1, and -2. This is the augmented matrix, que es the combination, the original matrix, o sea, the A matrix, que es the coefficients, is the matrix formed by the coefficient in front of the variable, and the right-hand side. So this is the right-hand side is B, it's a column vector, and that's it. And the software, in the software you don't put this line, no. You copy without the line. The line is in the piece of paper to understand that this is coefficient of the variable and this is not coefficient of the variable. But in the software that we are discussing in your moment, of course, we write the matrix like that, without the line to separate the coefficients. By the way, what is the dimension of this matrix, guys? Answer me. What is the dimension? Of this matrix? What is the dimension? How many rows? How many columns? How many rows? How many columns?
3 rows and 4 columns.
Say again.
3
How many rows?
3 rows.
3 rows. And how many columns?
4 columns.
Exactly, and that's it. 3 by 4. The dimension for this matrix is 3 by 4. The dimension is formed by number of rows. Look at that here. Explain here. Dimension is okay, and this is not a square matrix, right? Because the dimension of, so the number of rows is not equal the number of columns. Do you understand this? It's clear? It's clear? It's clear? Answer me. Clear or confusing? Because that's the first thing that you should do, no? Is translate to the system of equation to the matrix language. And after we manipulate. Everyone follow me or no? Come on, answer me.
Professor,
One question, come on. I hear one question. Professor,
yeah.
What?
The X is only for the dimension in the AX?
You say here.
Yeah.
You say this? Okay. This is confusing for you. I cannot explain it clear now. Okay, but in this case, is the formula is this. But I need to explain multiplication of the matrix after. So forget about that for a moment. Focus in that part, please. Do you understand 3 by 4?
Yes.
You understand 3 by 4? Yes or no?
Yes.
Okay. So are you help me now in this example? It's tricky. Suppose I have a system. X plus Y equal 20. Equation 1. C plus Y equal 40. Equation 2. And we have X plus 2Y plus 3C equals 60. Equation number 3. And my goal is write the augmented matrix associate with the system. Please help me to do that. We Entonces, how many unknown we have in the problem? How many unknown?
3.
Excellent. How do you know? 3. She said 3.
Because
what is the name?
it's X, Y, and Z.
Super. How many equations we have in that problem? Well, this is easy to remember to respond. That it's 3 again, no? It's 3. We have 3 unknown, and we have 3 equations, no? 1, 2, 3, right? Entonces, when the number of the unknown and the number of the equation is coincident, is 3, 3, 4, 4, 5, 5, that means that this system is determinate. Undeterminate, bueno, there are possibility to have solution. When it's undeterminate, let's see what is the idea. But determinate is perfect, define, matching, 100%, number of unknown and number of equations. There are another system that is under determining, under. And when you have, for example, you have 3 unknown, but we have only 2 equations. So we have like a, lack of information. Now let's see in your moment how you interpret it. Or another possibility is over-determined. Okay, over-determined, you have more equations than unknown. You have 5 equations, for example, and 3 unknown. It's another case that we studied. But no, I don't want to anticipate anything. The most important so far is determined. When the matching perfectly the amount of the unknown equation. In this case, we have the 3 possibilities: 1 solution, infinity many solution, or no solution. And here is different. Let's see in your moment. Okay, but I focus on my problem. I need to create a matrix. I open this big square bracket. Entonces es augmented matrix. Augmented matrix, remember, you separate by a line. In the right part of the line, you put a coefficient, que es 20, 40, and 60, right? Clear or no? And the organization. We reserve 1 column for the X, que es my first unknown, my first variable, 1 column for the Y, and 1 column for the Z. And you copy the number, one equation by one equation. This row is the equation 1, this one. This row is the equation 2. And this row is the equation 3. And you go, equation by equation. What is my first equation? X plus Y equal 20. Okay, there's 1 here, because the coefficient here is 1 in Y, and Z is missing. Z is missing is 0. Do you understand this? Who helped me with the second equation? To confuse you, in the original system gets given, I put completely disorganized the variable, pero no. The beauty of the matrix is you organize 1 column for the X, 1 column for the Y, and 1 column for the Z. And the second equation, what is the coefficient and the X?
0.
No, easy. What is the coefficient of the Y? 1, no? What is the coefficient Z? 1. This is my second equation in matrix language. And the last one is easy, and 1, 2, 3. End the story. You understand very well this? Look like easy, but it's important. Any question? Okay. Let me explain now the first.
No question.
No. Let me explain now the first algorithm. the first algorithm. Okay, let's call it Gauss elimination. We have two. So algorithm is a different step. Okay, you need to do to solve the system using matrix language. So we study one is called Gauss elimination. We study another case called Gauss-Jordan. Elimination. But what's the problem, guys? The problem is you are doing by the traditional way. I know it's too long, but this is not the problem. Okay, there are no one systematic way. Suppose you have 25 ways, and 25 or no. Okay, I try, but I select the equation 1 and equation 2 or equation 25. You get there are a lot of stupid possibility, no? Now the Gauss-Jordan elimination or Gauss elimination create a systematic procedure that you follow it and you never have problem. What is the idea? You have a matrix, suppose. You have a matrix, suppose. Entonces now I need to do something I want to explain after, not now. Focus in the algorithm to create one in the first number in the first and the row 1 in the column 1 you create one. Suppose that at the beginning, no, the answer is 5. When I do something to create one, this is important in the algorithm. I want to explain different technique to create one here. When you create the one, you're using this guy like a pivot. And pivot is the number that help me, pivot number 1. To continue. Now we are doing row operations. I want to explain in a few seconds. Row operations. In order to create 0 below the pivot. Suppose the example we have 4 equations. 1 pivot, and now you are doing now row operation. It's very, very, very similar to elimination that we studied before. Very, very similar. You see in a few seconds. And you create 0, 0, 0 below. This is the systematic. Another way is crazy. This is the good way. Now I continue. I continue to say I create again 1 in the second row. So row 2, column 2. You create another pivot. This is the pivot number 2. And this pivot number 2 help me to create 0 here and 0 here. And so on. Pivot number 3, 0. And pivot number 4. Yeah, I suppose that the rest is just a number. Okay, I have no idea what that. But in this moment, almost I solved the system. You can see clear in another example, no? Numerical example. This is Gauss elimination. Gauss-Jordan is a little bit more sophisticated. It's the same idea, but you find the pivot again and you create 0, 0, and 0. It's exactly the same. But you create the second pivot and you create 0, 0, not only below, below and above. In both directions. The third pivot is here. And the last pivot is here. And suppose we have here a number, and a number, and a number. And directly you get the answer. To see more clear, let's see example. Suppose this example I did. Don't ask me where come from this number, because there are several operations I explain in the next example. Suppose you have that system, 1, -2, 3, and 4. And 2, 1, -4, 3, -3, 4, and -1, and -2. This is the given. system, que es 3x4. Suppose I make a decision to apply Gauss elimination algorithm. Okay. Bueno, in several steps, I don't want to explain now. I explain in few minutes. We have that situation. So I want to illustrate the basic idea. How you get that is another problem. The layout of the algorithm. So it is 1 here, 0, 0. You don't understand how to create 0, 0, but I want to explain. 1 is the second pivot, 0. Here is -2. Don't change that. And 1 in the third one is -2 and 3. And here we have 4 and -1 and 2. Okay. So in this moment, this matrix is called echelon 4. Because it look like stairs, no? So in this moment, we can apply back substitution. What is that? Well, okay, remember that this is X, this is Y, this is Z, and this is right-hand side number, no? So you take the last equation say 0x plus 0y plus 1z equal to, wow, es obvio que C is equal to. Do you see that? Likewise, the second equation is no x, 1y minus 2z equal -1. Pero I know que C es 2, plugging in, back substitution, entonces y es minus 2 times 2 is equal -1, y minus 4 equal -1, y is equal positive 4 minus 1 que es 3. Okay. I have in my hand C. I have in my hand Y, que es 3. I need X. I substitution in the last equation, que es X minus 2Y plus 3Z equal 4. Entonces X alone minus 2 times 2 plus 3 times 3 is equal 4, ¿no? Entonces this is -4, positive 9 equal 4. Then is 2 times 2 is 4, 3 times 3 is 9, no? 3 times 3 is X plus 5 equal 4, no? F 4, yeah. Therefore, the answer is C is 3, but C is 2. I make a mistake here, guys. It's easy, but I make a mistake. Look. X is X. Y is 3. And C is 2. Equal 4. Entonces this is 4. Because this is 6. And this is 6. Cancel out the 6. X equal 4. And the solution is the point 4, 3, 2. This is the answer. Okay, let me summarize. Okay, using row operation, you don't know what is a row operation, but it's very, very similar to elimination. We go from this matrix to this matrix. And this matrix is echelon 4. Echelon because it's like a diagonal. So you see in the main diagonal, get 1, 1, 1, 1, 1, 1, 1, 1, 1, and below this 1, 1, we have only 0. This is a typical echelon. And the rest is just a number. And you have, again, you come back to the system of equation, you solve the system, and you get the solution, que is 4, 3, 2. Okay. Now, suppose I make a decision doing by It's a little bit more long, but it's fantastic because when you are doing from this matrix to the Gauss-Jordan matrix, we have that new matrix, que es 1, 0, 0, 0, 1, 0, 0, 0, 1. Remember, we elimination not only below the pivots, below and above the pivot, and we have 4, 3, and 2. Okay, now I go from the major language to equation. The first equation, remember, this is x, this is y, this is z, and this is the right-hand side number, right? The first equation is 1x plus 0y plus 0z equal 4. It's obvious that this part is missing because it's 0, therefore x is equal 4. Likewise, y is equal 3 and z is equal 2. It's too long process, however, we determine directly without back substitution the value. Okay, I know that you have a lot of questions because you don't know what is the row operations. Okay, entonces this is called, this matrix now is called reduced row echelon. It's the name. So this matrix can contain only in the main diagonal 1, 1, 1, 1. I call main diagonal, guys, first row, first column, second row, second column, third row, second, third row, third column, 1, 1, 1, and the rest is 0. It's super easy directly solve the system. Okay, do you understand the basic idea? Okay, so now I go to explain now what is row operation. It's relatively easy to understand because it's similar to the thing we are doing before of the elimination. So we have basic 3 row operations. May I erase the board or no?
Yes.
Okay. I know that the story is incomplete. Now, little by little, you approach it to the goal. Okay, I want to explain. We have 3 row operations. Elementary row operation. Elementary row operations. Okay, the first one is called interchange. Two row. Some software call it swap. Two row. And the symbolic way to indicate this is R1 suppose R2. Interchange. This is perfect valid because remember this is a system and you write in metric language, but each row is an equation and doesn't matter the order of the equation. I call 1, 2, 3 or So it's perfect possible. So what is the application of this, professor? One of the application is because you want, for example, 1 in the first pivot. So you try to find in the system what is the equation que have 1 in the first column. Is this to you swap? For example, to understand this, I have this equation 2, -5, 3, 2, the bar que separate right hand side and the coefficients because it's augmented matrix. I interchange. So the operation that I'm doing is row 1 interchange swap row 2. Remember, this is row 1. This guy is row 1. And this guy is row 2, no? Okay, this is super easy. And you put a row 2 first, 3 to 17, and 2, negative 5, 5. Maybe you don't understand very well the application of this now, but in one example, remember we need, let me try to put a good example to understand this. Suppose in one hypothetical problem, I have this equation, 2, 3, 4, 5. This is the line. 1, 2, 3, 6, 10, 20, 30, 40. See, I make a decision to apply Gauss-Jordan or Gauss elimination, either one. I need the first pivot 1. So the first operation that the algorithm doing is interchange row 1 and row 2. So now my new is 1, 2, 3, 6, 2, 3, 4, 5, and the rest stays the same, 10, 20, 30, and 40. And I guarantee you, wow, amazing. I guarantee you now my first pivot here to start. Got it? Entonces swap, 2 row, es perfect valid. 2 column, no, it's illegal. You see in another algorithm that you can, but in this, no. In Gauss-Jordan and Gauss elimination, no. Es interchange 2 row. Column, no. Column is after I explain, pero in another thing. Another row operation is number 2 row operation is multiply a row by non-zero constant. Suppose again the same example. Easy, no big deal, not complicated. 2, negative 5, 5, 3, 2, 17, no? And you make a decision to perform that operation. And so let me try to understand the language. 3 R1 stores in R1. What mean that? Can you take the row 1, guess this, multiply by the constant, in this example 3, and the new row store in the same position of the row 1. So it's 6, negative 15, 15 positive, no? And the other, no, the other stays the same because I don't touch row 2. I only operate row 1. And it's a perfect valid. And it's a perfect valid because remember when you are doing elimination, you multiply equation number 1 by 3 or by negative 3 according to our convenience, right? So this is no new for you. Okay? The problem is integrate everything in the algorithm. And the algorithm following the pivot, below the pivot. Another arrangement is no good. This is the systematic. Because si you make a decision, another simplification, maybe the work you are doing before, you screw up. You delete some. So now, so you're following this procedure, you have no problem. You see in the example, it's hard to explain because it's too long process, no? But it's easy. Okay, the third row operation is the last one. So you have only 3 row operation. Is at, pay attention because this is a little bit complicated to understand. And multiply of one row to another row. And we come back again to the same example. 2, negative 5, 5, 3, 2, 17. Yeah, I need to perform because I need. So you say, well, professor, and how do you know the operation that you should do? So I need to, when I finish to explain the row operation definitions and the new example, you see how you select the row operation to solve it. Suppose hypothetically, I am doing this row operation. 2R1 plus R2, storage, and R2. Wow, what the hell is that? Well, okay, your multiplication, row 1 gets this. By 2, similar to this. Plus row 2 in the corresponding column, no? And the new information you store in the row 2. That means in this row operation, the row 1 participate but don't change, because the final answer is storage in row 2. And the only row get changed in row 2. You multiply. These two gets a constant, times 2 is 4, plus 3 is 7. You follow me? So it's 2 times 2 plus 3, no? What is that? This is row 1 and this is row 2. Okay? Now, in this position is 2 times negative 5 is negative 10, and negative 10 plus 2 is negative 8. Now, finally, it's 2 times 5 is 10. 10 plus 17 is 27. Do you understand the operation or no? Or explain again? Understand or explain again?
If you can explain it again.
Yeah. No problem. Okay, look. Let me try here. Let me try to do my best. This is row 1, row 2. And the first calculation, you have 2, but this 2 is this 2. No, it's this 2 or this 2. It's a coincidence. It's one arbitrary coefficient, guys. Select. Multiplication by row 1, the entire row 1, and row 1 is 2, negative 5, and 5. So it's, let me copy several times. 2, 2, 3, 2. We have 2, guess these 2. Negative 5, guess this, and positive 5. This is row 1, this guy, plus. Row 2 is 3, and the corresponding column, guys, 2. And 17. Let me see. 2 times 2 is 4, plus 3 is 7. This 7 is this. And this new information that you compute in that bar, you storage and located in the row, new row. This is a new. This is the old. Entonces negative 10 is negative 8, and this is 10, 27. Got it now? You understand now or no?
Yeah,
Yes.
understand.
Okay. So now, in the time that we have, let me try to do one complete problem. Okay, include everything that we studied so far. Include number 1, translation from the system of equation to the matrix language. And you apply several row operations step by step. And you see, wow, professor, but this is very tedious doing by hand. Of course, I understand. I never ask you this, because everyone make a mistake. One stupid mistake you make in one operation, you screw up everything. However, there are software. That is the reason that the mathematicians create this algorithm, because the algorithm you can program it in the computer, and the computer never make a mistake and following too fast several steps, 1,000 steps in seconds. Okay? So nobody, this is tedious problem by hand. This is not hard, it's tedious, it's long, stupid, consuming time, no? Suppose that system. Suppose that system. 3x plus 7y minus 15z equal negative 12. This is my equation 1. X plus 2y minus 4z equal negative 3. 2. Negative 4x minus 6y plus 15z equal 16. Well, okay, so you are doing by hand in the test, you take equation 1 and equation 3 and elimination 15, right? But no, this is not the idea. This idea, suppose que it's good idea, but you have more equation, 20 equation. This is crazy. No. Okay, so let's do it in the way we are learning today. We set out the matrix associated with the system. Of course, augmented matrix. 3, 7, negative 15, and negative 12. And x, no, 1, sorry, no variable. In the matrix, only number. 1, 2, negative 4, negative 3. Negative 4, negative 6, 15, and 16. This is my original matrix. By the way, the dimension is 3 by 4, no? 3 column. It's obvious que 3 column because we have 3 equations, no? And it's obvious that we have 4 column because we have the 3 unknown, que is the classical x, y, and z. And we have the right hand side that you include inside because it's augmented matrix. Entonces, suppose que I want to do using Gauss elimination, and after we continue using Gauss-Jordan. Because Gauss elimination is one first part of the Gauss-Jordan, no? Okay, the first thing, remember, is create the pivot. So I create somehow, using your imagination, your common sense. Maybe you say, well, professor, divided by 3. Yeah, you can. But to avoid fractions, I propose you swap row 1 and row 2. Because I saw, wow, amazing. I like this one. This one would be fantastic. You put it here. You swap. So 1, 2, negative 4, negative 3, 3, 7, negative 15, and negative 12, no? And negative 4, and negative 6, and 15, and 16. Like you see, the row number 3, no participate in this game, stay the same, and row 2 and row 1, yes, change, so swap. Now the most important moment. Okay, listen to me. Suppose now I need to apply several row operations in order to create below the pivot. Okay, by the way, this is the pivot 1, 0 in here, so instead of 3, 0 here and 0 and negative 4. Pero no, step by step. 0 and 3, another step is 0 and negative 4. So what is the idea? The idea is easy. You take row operation, but on row operation number 3, que is multiplied by a constant. How do you know what is the constant? It's the same value, 3, but opposite sign. It's negative 3. So you multiply negative 3 times row 1. Why row 1? Because it's the row that contains the pivot. Plus row 2, and stores this information in the row 2. You are doing your job. Let's do it. 1, 2, negative 4, and negative 3 stay the same. Likewise, negative 4, negative 6, and 15, and 16, no change. Doesn't change. Now this is change because negative 3, listen to me, time positive 1 is negative 3, plus 3 is 0. Do you see where I come from this 0? Likewise, negative 3 times 2 is negative 6. Plus 7 is negative 3. Es 1, ¿no? Ahora es negative 3. Negative 3 times 2 is negative 6. Plus 7 is 1. Do you see where I come from this one? Now, negative 3 times negative 4 is 12. And 12 minus 15 is negative 3. And last is negative 3 times negative 3 is positive 9. And positive 9 minus 12 is negative 3 again. It's a coincidence. Do you see or no? Complicated, right? Let me try. Minus 3 times R1 plus R2 stored in R2. Who is R1? Is 1, is 3, is obviously 0. Who is now R1? Is 2. Plus 7 is 1. And negative 3 times negative 4 is the third one. Minus 18 is negative 3 because this is positive 12, no? And negative 3 is the factor, the famous factor, multiplication by negative 3 again. Minus 12, this is negative 3 again. Do you see now or no clear? Yes or no? Come on, answer me. I know that this is a little bit confusing, no, at the beginning. Actually,
what was the question?
No, I say, do you follow me?
Oh, yeah. Sorry.
What is the answer? What is your answer? Yes or no? Come on, guy. This is a lecture or no?
Yes.
Okay. You have some idea what is the next operation that you should do? Remember the strategy of the Gauss elimination. I create the first pivot here, right? Now I need to create the second pivot below. When I finish the first column, I move on to the second column. Okay? Entonces, who can do that? The equation of the operation you need to apply to create 0 here in the third row and the last number of the first column. What is the factor? No idea. The factor is 4. Where come from this 4? It's the same number but opposite side. Then you multiply the row that contains the pivot. This is important, guy. 1 plus row 3. And store this new information in the row 3. Therefore, row 1 and row 3 stay the same. The only thing that changed is row 3. Entonces 4 times 1 is 4, positive, minus 4 is 0. You understand where I come from this 0? 4 times 2 is 8. 4 times 2 is 8. 8 minus 6 is 2. 4 times negative 4 is negative 16. And negative 16 plus 15 positive is negative 1. And finally, 4 times 3 is negative 12. And negative 12 plus 16 is 4. Positive 4. You follow me? Yeah, I finish the first column. Look at this, the format. Pivot number 1 and below the pivot number 1, just 0. Bam, 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 bam. Let's move on to the second column now. I finished the column 1. Now I move on to the column 2. I finish with the column 3. Okay, I copy now. I copy now. Column, I copy now. Remember, this is a sequence. Entonces, I don't want to extend it too much, this whiteboard. I just copy this again. Yeah, I planning my second stage. Okay, working with the column 2. This is the big, wow, nice. I appreciate so much that somebody put 1 here. I create intentionally, you know, it's too much. So now I need to create 0 below the people, no? So what is the row operation? Okay, you should do. Somebody there to give me equations. So the thing I ask you now is this equation. It's a part of the game. Try to find the row operation to make 0 here. Nobody know? Come on, guy. You pay attention. Or say no, professor, I don't know.
Multiply by negative 2.
I like that to hear that. Multiply by negative who? So the coefficient is negative 2. Okay, negative 2. I agree with you 100%. Negative 2 because it's positive 2, negative 2. Entonces, what is the row que contain the pivot in this column 2? What number of row? Is row 1 again or is row 2?
Row 2.
Excellent. Plus the row in which you want to affect elimination, store, and row 3. It's doing 1, 2, negative 4, negative 3, 0, 1, negative 3, negative 3. This is the crucial moment. Well, 0 stays the same, right? Because look. Negative 2 times 0 is 0 plus 0 is 0. This is the reason you need to follow in this order. Si you select another stupid order, you make a mistake. This is the order que discovered Gauss. Okay, now, negative 2 times 1 is negative 2 plus 2 is 0. This was my intention in this step. Okay, now, negative 2 times negative 3 is positive 6 minus 1 is 5. Repeat again. Negative 2 times negative 3 is positive 6 minus 1 is 5. And negative 2 times negative 3 is positive 6 plus 4 is 10. It's okay? This is okay or no?
Yes.
Well, so what do you propose me now? I finished. We are ready to back substitution or no? Well, yes. But I want to refine a little bit more clear. I apply just because I want to explain the row operation in detail, no? I put the swap here. I copy the add, multiply, add, but I now multiply only, Suppose you multiply the third equation, the third row, sorry, not equation, yeah, divided by 5, 1/5, and stores in R3. Well, entonces row 1 and 2 stay the same, doesn't change. But it's changed. 0, 0, 1, and 2. Do you see that? Because 5 divided by 5 is 1, and 10 divided by 5 is 2. So remember, this is x, y, z. It's obvious that the last equation, yeah, this matrix is expressed in echelon form. If it's in echelon form, we are ready to apply back substitution to say CS2. It's obvious CS2. So you don't see very well. Let me write the last row like equation. 0x plus 0y plus 1z equal to 0 is nothing, a raised apart, and 1 is invisible multiplier, CS2. And the second equation is y minus 3z equal minus 3. Substitution here. Y minus 3 times 2 equal minus 3. Y minus 6 equal minus 3. Y is equal minus 3 plus 6. Y is equal 3. And x is, well, you take the original, x plus 2y, but I know the y is 3, minus 4c gets 2 equal negative 3. X plus 6 minus 8 equal minus 3. X is equal, no equal, it's a minus 2 equal minus 3. X is equal minus 3 plus 2, okay, negative 1. And the solution for this system is negative 1, 3, 2. Okay. No, I don't want to finish this. I want to explain the first part of the process. I don't know if we have time today. We continue next time. Continue with the Gauss-Jordan. Okay, Gauss-Jordan is in another direction. Everyone follow me? I can erase that part?
Yes.
Yeah, because this part is easy. That part is elementary. The back substitution is super easy. Okay, suppose to illustrate you the power of this part. I continue with the no Gauss eliminations, Gauss-Jordan. Gauss-Jordan, remember, in each pivot, you elimination not only below, below and above. So I propose you doing, doesn't matter, the order is not important now. Suppose that the row operation I propose you is 4R3 plus R1 stores in R1. Look, I take advantage of that pivot, multiply by negative 4, by positive 4, sorry, is the opposite sign of this. When you adding, when the row 1, I create 0 here. So 0, 1, negative 3, and negative 3 stay the same. 0, 0, 1, and 2 stay the same. Now the row change is the row 1. This is 1 because 4 times 0 is 0 plus 1 is 1, it's obvious. And 4 times 0 is 0 plus 2 is 2. Oh, it stays the same. This is the beauty of that. Okay, the part that you are doing is stay the same. However, now 4 times 1 is 4, plus minus 4 is 0. This was the intention for this operation. Create 0 here. And here 5. Why 5? Because 4 times 2 is 8. 8 minus 3 is 5. Okay. Almost. Let's continue in the same direction. Suppose now, okay, want to create 0 here. So 3, R3 plus R2 stores in R2. Guys, I want to go fast. I copy the answer, you talk to me, okay, I do well. 1, 2, 0, 0, 1, 0, 5, 3, 0, 0, 1, 2. And finally, I need to create this 0 in the place of 2. So the row operation that I propose is negative 2, row 2 plus row 1 stored in row 1. when you are doing this operation, you have 1, 0, 0, 0, 1, 0, 0, 0, 1. Wow, amazing. And the right hand side, we have negative 1, 3, and 2. Okay, it's exact equation by equation. Look, the first equation is 1x, no y, no z is equal to negative 1. Therefore, x is negative 1. The second equation is no x, 1y, 0z is equal to 3. Therefore, z is 3. And the last equation is no z, no x, sorry, no y, 1z equal to z is 2. And we get exactly the same solution, que es the solution negative 1, 3, 2. Okay? Okay. You don't need to do this. I explain because this is cultural, no? To understand the idea behind the algorithm. Because I want to explain in the next class where or how we can do using the computer, right? Well, there are many software, but I prefer one software. I present to you the software. We are doing several examples, but we are doing several examples in 5 seconds because the computer are doing too fast, and the computer select the row operation in each step perfectly. Okay. Okay. Entonces I propose a stop. Remember, today is the last day today at midnight to send me the reading test and submit online in Alex the test too. Okay, please, I appreciate so much. Can you send me the reading test no in pictures, in PDF format, que is the best way to see. The picture is not clear to grade that. And also, don't worry for the question word problem of the linear programming in Alex. If you make it wrong answer, it's because they are stupid. You are doing well, however, when you put here some a little bit different and to say grade wrong. No. If you email me, I fix it. Okay? Okay, do you understand? Are you clear? You are confusing.
You're clear, Professor.
Clear.
Clear. Thank you.
Any problem, any issue, any problem, you communicate personally with me by email, not here. Professor, no. This is a lecture, this is mathematics only. You email me, I understand the problem, I fix the problem, and that's it. Correct?
So you want the exam in PDF, correct?
Yeah, please. Appreciate so much PDF. Picture is horrible. I don't see very well, so I cannot read. Super good.
Put the Desmo stuff in the PDF too?
Yeah, of course. Okay, you create like a image and Desmo no, and you attach to the document. The graph in Desmo. Never
Okay,
by
I
hand.
understand.
This is by hand is
Okay.
antique. Hello. Okay, guys, appreciate so much. See you don't receive the email this Thursday. Sorry, this week is because of holiday. And you enjoy. Okay?
Thank
Okay.
you. Have a great day.
Bye,
Thank you,
Professor.
Professor.
Thank you,
Have a
Professor.
nice day.
Bye.
Have a nice day.
Bye, Professor. Have an amazing day.